Assalamu alaikum and welcome to my channel. Today we will be performing 12 added operations and ALU arithmetic logic unit operations on quartus. So let's start with it. First of all, we would be simply performing a simple added operation. Um, I've already done the circuit, so I would be simply opening out adder. So this is a simple adder operations with including of Cin means carry in. Carry in is included in this simple adder operation. I have done it without carry in as well, but first of all we would be discussing about the carry in operation. It is a simple circuit containing the simple modules of the Verilog operations. So first of all, we would simply be going on with the starting of the Verilog code by implementing of the module name of the file. Then the all the inputs and output involved in this circuit, that would be sum A, B, and Cn. I named my inputs as A and B. You can also name them as you wish. You can. So first of all, I would be implementing an 8-bit circuit. So I would be implementing it with 7 and 0. We can also implement it otherwise. We can also make by simply changing these values. I can make it a 2-bit adder or a 4-bit adder as per requirement and as wish. So first of all, the two inputs that I have taken are input 1, that is A, and then input 2. You can also write this whole sentence in one line, but I have included this in two different lines. Then this there is input as C in carry in. Carry in would not be exceeding from a 2-bit adder. That would just be having a carry in would be having just a 0 or 1. It cannot be exceeded any further operations, any further options. Otherwise, the carry input would not be implemented as we wanted. So after this, there is an output, that is we have included a sum, a same 8-bit adder, 8-bit subtract sum. Result would be in 8-bit. Now we would simply write a sign, and the function would be sum is equal to A plus B plus carry in, and that would be end of the module. I've already performed this function, and I'll be showing you here. The performed function, or otherwise it would be taking some time that we would not be necessarily needing. So this was our function that I have already shown you. So its Rtl view is this. So if you want to see it, this is its Rtl view. As the carry input is only 0 and 1, so it is going from all of the 8 outputs. So all of the 8 outputs would be resulting in the sum would be 1. So it has gone from 8 of the outputs and it is resulting in 1. Now the next part was the output result. So this is the waveform that have been produced. I have simply added a carry input as 1 and added as A is equals to 2 in logical units and 4 in B. 2 plus 4 is equals to 6, and that plus the carry input over here, we would be getting this of the result, and that is logically also proved. Then after that, we would be going to the next of the circuit. We have performed different implementation. We have included carry in, and we have also included carry output. For example, for the first example, I have taken a simple circuit without having carry inputs. I will be showing you. So this circuit would not be having carry input over here, as you can see. So this has I've simplified it to a much simpler level. Later on, when I would be introducing arithmetic logic unit, then also at that time I would be using this to simplify the circuit. Or we can also add a carry input, but it would just for So this is the circuit that is produced. You can simply see there are two inputs and simple addition added included in the middle and some the output. Now let's see its output. So this is a whole output that I have opened all the values of for the bit so that you can see it. I have simply randomly chosen a where the value of a and the value of b, and the resulting sum when it performed, so the resulting sum is the accurate result that if we include the addition function it would be giving us this result. Sorry. So this is the addition, and this is the closed view of it, and a simple waveform that is over here. After this we would be searching of So after this, we would be switching off our next example that would be having including of the carry outputs. Now these are the waveforms first, and then I'll be showing. So this is our code. This is our basically a code that we have named that carry outputs would be, instead of carry input, I have included carry output. And here the inputs are will be the same, but the input instead of input carry in there is output carry out. That is a small change over here. Then I've also included a wire 10 that is 80. Now it has one bit increased, so that 7 bit of the sum would be included in this, and the last bit that would be included, that would be the carry output that would be left. So I've simply done that. Assign the temperature temp is equals to this our variable temp is equals to a plus b, and the sum is equals to assign the sum is equals to 10 7 0, which means that the sum is this is the 8 bit operation of the 10, but the carry output is equals to cam 8, which means that the last value, the last digit of the value or temp, that would be towards the um, left towards the left. The last input that would be of carry output would be this. I can also show you over here that how I would be explaining it. I simply open up the, so what I meant to say is like when we add one, like I'll just be going for one, one, one. So this is a simple. I've reduced the bits of to just explain it. 0 plus 1, 1. 1 plus 1, 0 would be going here, and carry output would be resulting over here. This one that would be going over here would be resulting into the carry output. So uh, let's see what our result would be. So our circuit that would be formed, the Rtl view of this circuit would be this. So you can see over here that a and b simple addition adder function is involved, but the eighth output, as you can see, the eighth output would be implemented over the carry output. Now I have found two types. One is when the carry output result is 0, and one is when carry output result is 1. So how to explain it? So first of all, this was my random options of values for A and B. As you can see that when we add them, the result would be this, and the result would not be exceeding to the next input. So that means that the result, for example, we take this um, as the value as the sum of a b. So the sum would be 1 and 1. There is no carry produced over here. 0 carry is produced, or carry output is produced. So this means the carry output would be resulted to be 0 here. So simply the carry output, as you can see, is over here 0. Now the next time b is 1, and when we add this 1 it would also be equals to 1, so that the carry output would be generated. So this waveform would be produced. So this was one of more examples. So now what we would be doing, that we would be including both carry input as well as carry output. So what would be the result form? So this is a circuit that we have produced. This is a complete adder that has both in carry input as well and carry output as well. So what would be the change in the circuit would be that that we would be simply, as we have included in the previous one, we would be adding it as carry input as C in. Then we would also be adding that output carry out is equal to carry out C out. The divider would be the same and the value of carry output would be also the same, and some value would be the same. Just the difference would be created at the value of temp. Temp now at the temp would be A plus B plus C in. So there is a little bit difference over here, that C in is included else than the value. So what would be the circuit? The circuit produced, or when we see it RTL view is somewhat like this. So when we were doing the CSC, the second example that I showed you in the starting, in that we have included the C in only and C out was not present. The same type of circuit was also being produced, and I told you that as C in just C just 0 or 1, so it is simply added to all and its result is given it out over here. Excuse me. So now in this, what in this one, I have carry output that is the ETH value that is producing the extra one. So we simply go. It is simply the same circuit until here a carry out is include and this result in the formation of the circuit. So let's see the waveform. So this is the waveform produced over here. Carry input is 1 and the value of A and B is this. When we run the circuit, the sum is this, but there it would be carry output produced. Why so? Because 1 1 would be here. First of all, carry input would be added, 1 plus 1 is equal to 1, 0, or 1 is carried over here, then 1 added to this. So this would be, I would be reducing to somewhat to just explain it. So reducing the bit and just simplifying the circuit to explain you uh, the what is actually happening over here. So this is what is most closest to A and B this in this function. I've eliminated a few of the zeros over here just to explain the concept. The carry input would be included over here as temperature. This is carry input. Okay. So this is reduce over here. So 1 plus 1 is equals to 0. 1 carries over here. This will go 0, 0, 1 as it is 0, 0, 0, 0. And this 1, 1 would be going to 0 and the carry output would be generated. So this carry output would simply be going again to carry output and the result would be 1, 0, 1. And this result is absolutely the same. So now we would be going to our fifth example, that would be of the day. In this fifth example, we would not only be looking at the adder, but we would also be looking to the subtractor as well. Now in this I've used two methods. I've used two codes and they made two different perspectives. First one is this code. This is this is simple code using the function of if and else, it's the same. But in this, I have used here instead of plus addition and subtraction, I have used is and or symbols. so, so in this, let's start with it. And in not, sorry, and in excuse me. So first of all, the module is same, inputs are same, output regulations are produced, sum and C out same. Then after that, I have included regulation of C plus. Regulation C. What does this mean, regulation C? So once again, I have modified the circuit so that I could explain it. Uh, I had done an extra one of this. explain you what else happened. I named them differently just to explain what I was doing in stepwise. Yes, so this is my circuit on quartus. So simply I've done is module simply add adder with subtractor. Simply this is all the circuits are same. Now the red is temporary. The value that we had first included as the divider in previous one. Now in this in this code I have included it as temp regulatory. Means the variable value. Next is integer. That was the in our question. It was given that we have to add an input of select s1 that would differentiate between the do it operation we would be like to invite in it, either addition or subtraction. So this s would be giving us the value that we would be requiring, that we would be switching between addition or subtraction operation. That will be found. Now, in simply when we go for always, we have include all the values or inputs A or B or C or in. Then we begin to simply write begin. That begins. Then temperature. Now we have included the temperature 0 is equal to C in. The temperature value of 0, the temp value of 0 bit is of C in. That would be our carry in. We produce if the carry input is equal to 0. First we have declared that C in value is 0. Now we are declaring that if C in value is 0 0, then begin with the code if else. Okay, my code just got dropped off. Okay. So now it's like, okay, so it would be if for the value of if 0 0, then for 0 until it is reached is smaller than 8, which means 7, this s value plus 1, that would be 1, would be sum s, means sum 0 is equals to a bar a over b s uh, c temporary s. Now, what does that mean? Instead of this, we would be removing the signs over here. So, what would this be producing if we remove the signs over here? So, what will happen? We are simply giving it an instruction. We are simply giving it an instruction that would have been given over here. That would be exclusive OR gate. Now, exclusive OR gate implementation is present over here, and then we have temporary value s plus 1, that would be 0 plus 1 is equals to a and s b and or s and a s a, the value a 0 and b 0 for the first, and right now I'm just talking about the first value, that would be when s is equal to 0. I'm not talking about the first 1 2 3 and up to 7. First time 0, odd a plus 0 plus temp 0 or a plus b a plus 0 b 0 and temp 0. So we would, so we are writing it over here, we would do, it would be something like um okay, sorry, it's really big. Okay, so it would be something like a, okay, without eliminating this, um, it would be a dot b plus b a dot temp. I'm representing temp te plus b dot temp. So this would be resultant answer of temp s1. So that would be result. So if but this case ended up over here when we ended up and we end the first case, first if statement. Now then we say that else if. Means if Cn is not equals to 0, Cn is equals to 1, that are the only two inputs that are given to it, then the value of s is the same for loop is applied, and then the sum we say when we say the array value of sum is equals to, then here now it is a negative not of p. This means that there is subtraction involved in it. As you all see that b value is negative in all of that means that there is a not yet present before b, and that will be giving us the same half subtractor value. Then as we know the circuit, then if we see the circuit of half adder, half subtractor, I have the half subtractor value. So if we see the half subtractor circuit, it is the same, that is it. So in this you can see the b value is negative, a value is negative, but we have included as b value is negative. So let's move forward, and here we can easily differentiate that this here over here, this is a subtraction function forming, and over here addition function is forming. So that we enter module and see what is the result forming. So going to the result. So this is the massive circuit that is produced due to 8-bit unsigned adder and subtractor circuit. You can also see mux over here. So let's move on forward to the uh, to its graph, to its waveform. So method one we have already seen. This would be the method. Okay. So we would be saying method the one with that we have already discussed, the simple method output. So this would be its output. You can see that I have selected as 0 as 1, so this means that it would be negative in subtraction form, and there is subtraction forming in here. Okay, then next method is the next module is this one. So in this there is a simple code written over here, no included of extra if and else and more complications. The code we have previously done, it is the same code present over here. We simply go for in drag output drag sub as sum and subtraction, carry output temp means the reg so wire we include a cell. Now here we include survivor cell. We simply always that all the inputs. Then if selection is wire is equals to 0. Now if selection wire is equals to 0, then the temperature would be addition form, and the sum is equals to temp 0, or the carry output is equals to 8 value of temp, and that's it, and that's this result that we have done already. And this subtraction function is also there, the b like is there, and this result is absolutely same. Now what we see, we want to see that how does it performs its Rtl view. So here is it Rtl view, much simpler than the first one, and it results in the same answer. Now in this the subtraction is not involved as in the first one, because right now the value of Cn is 0. As you can see here that I've selected one, then the result of the select subtraction is absolutely the same. So we have got the right answer. Now let's move forward to our exercise, that would be of elimini. LU means arithmetic logic circuits. But this is one of the circuit, one of the what I have produced. So this is the simplest circuit. First I used if statement. First I was going simply for assigned statements, and we have simply performed our circuit. Now I would be then I used if else statements, and now I would be proceeding on towards case statements over here. I have produced 10 operations of elu over here, whereas there are multiple of options that it produced. They include addition, subtraction, multiplication, division, all the arithmetic and logical operations as well. So then all the now logical gates operations. If we, so first of all, what does an LU means and what does it its importance in our daily life and in especially in digital logic designs. LU especially is an abbreviation which means arithmetic logical units. Now, if you simply go for its name, you can already understand what does LU actually means. LU actually means arithmetic means it forms all the arithmetic operations. Logical means it all the forms logical operation with logical gates operations. And that unit means a single unit that is performing all the arithmetic logical unit logical operations that in single unit that is LU. Now, what is its significance? Significance of LU is highly and greatly modified in DLD. In DLD and in any of the processor and computer devices, it is highly occupied, offered. So, what is the value? Now, simply as we have previously, I have previously shown you the different some that I've produced and how I have to make different for CC in. I have to make this sort the out. I've select different selection and multiple selections I've used just to carry out a simple circuit. But in this LU, I would be simply just changing the selection, and that would be resulting in giving me the answer, giving me the appropriate operation that I would be requiring. So first of all, I have done what I have done. I have simply changed, taken everything as the same as the previous one. Most of the things are the same one. I have not included carry input that because it was making the skill circuit more complex. You can also add carry input and result would not be affected like that. Okay, so first of all, I have always taken this. This means that in the answer of in the A is sensitive. What does that mean? That means that if we take an operation of A plus B, A is equal to B plus C, and this operation is there, that means that the A is sensitive value, means the A value is consecutively changing and it is sensitive value. So let's move forward to what is the circuit begin code begin with case select. We have chosen select. That case option is select. Then if the all 4 bit is equals to 0, then operation is equals to A plus B, means addition is happening. If 0 is 1, then subtraction. Then division, then multiplication. If B is 101 means this is the 1, 2, 3, 4, 5, fifth operation. Fifth operation is if A is bigger than B. Then if A is bigger, then we have written this code. And then the next one is this not null of no NAND gate. This is and this is not symbol. So this means NAND gate operation. Then we have included as A is equals to B, then the operation is wrong. Then the eighth one we have simple produced an AND operation. Then a simple or an XOR operation, and it's the simple of OR operations. Then we have written as that in default the circuit would simply be giving an addition something. If in default if any of these are not chosen and any other values choose, then this simply would be giving a default value. Then we have ended the case, ended the module, and this is the simplest small code that we could ever. Now, what is the this would be the RTL view. As you can see, all of the operations and or exclusion or addition, subtraction, multiplication, all of the circuits are being produced. So let's go forward to the waveform. This is the waveform that would be here. I have selected Z000. The result would be this produced. With value of this is 0. Carry output is 0 because no carry is produced on the top. I've selected 0 0, which means addition, as over here 0 0 addition. So addition, with this addition the result would be giving the same. The result is absolutely correct. So now here we end of our explanation of LU and different logical circuits. Hope you understood it, and thank you very much, and Jazakallah.